The audience for this video include hardware and software engineers developing ESP32 microcontroller-based projects. This ESP32 microcontroller project shows how to use two of its digital pins to represent from 1 to 4 different hardware configurations. I use this when I put together 4 different temperature transmitters placed in 4 different locations at my home. I wanted to use the same sketch in all 4 ESP32s and have it examine the digital pin wiring to identify its location within my home. This image shows ESP32 pin 0 and pin 1 both wired to ground using PCB hole numbers 13 and 12 respectively. A digital read on either pin 0 or pin 1 delivers a low 0 voltage condition. This image shows ESP32 pin 0 wired to ground using PCB hole number 13, and pin 1 is not wired to ground using PCB hole number 12. A digital read on pin 0 will return low, meaning 0. This image shows ESP32 pin 0 is not wired to ground using PCB hole number 13, and ESP32 pin 1 is wired to ground using PCB hole number 12. A digital read on pin 0 will return high and pin 1 will return low. This image shows ESP32 pin 0 and pin 1 are not wired to ground using PCB holes 13 and 12. Digital reads will deliver high on both pins. This sketch is named Demo 8. This ESP32 microcontroller project shows how to use 2 of its digital pins to represent from 1 to 4 different hardware configurations. I use this when I put together 4 independent ESP32 temperature transmitters placed in 4 different locations at my home. I wanted to use the same sketch in all 4 ESP32s and have the sketch determine the digital pin wiring to identify which ESP32 is transmitting its temperature readings. In this sketch, when the ESP32s are powered on, the pinMode input_pull-up is used to force 3.3 volts on both pins 0 and pin 1 to avoid any possible random erroneous voltage readings. Wiring ground 0 volts to an input pin will override the pinMode input_pull-up because the direct wire creates a short, low resistance path that easily overpowers the weak, high resistance pull-up. For simplicity, this sketch only includes the relevant statements that test the ESP32's digital pin 0 and pin 1 to identify which of the 4 ESP32s is running the current sketch. In the full program sketch, not shown here, the location and temperature information from the 4 different ESP32 transmitter units are transmitted to a 5th ESP32 that hosts a website that can be viewed by a mobile device such as a cell phone, tablet, laptop, or desktop to see the ESP32 locations and temperature information summarized into a single web page display. That sketch will be demonstrated and explained in a future video. Here I'm defining pin 0 and pin 1 of the ESP32, and I'm also setting up a variable named location where I will store the words location 1, location 2, location 3, or location 4, depending on which ESP32 transmits the information. Here, I'm using the pin mode to set pin 0 and pin 1 at a high state using that input pull-up. They're both set to default to the high conditions, 3.3 volts each. Immediately afterwards, I begin testing to see if any ground wires are wired to pin 0 or pin 1. And this is where the logic quickly identifies which ESP32 is transmitting the temperature information. And these statements below here show my software development environment. I'm running Microsoft Windows 11. I'm Arduino IDE version 2.3.6, and I'm using an ESP32C6 that's made by Espressif Systems.